Good afternoon, everybody. We still have quite a few folks joining us, so we'll wait a few more minutes before we get started, but welcome. Okay, good afternoon, everyone. And for those attending from the West Coast, good morning. Welcome. My name is Paul Lefebvre, and I'm the Business Development Executive here with MBSI WAV. And I'm excited today to introduce one of our partners, RF Elements, to our webinar. They will be reviewing their innovative product line of noise rejecting antennas, how they work, and the compatibility with most radio manufacturers such as Ubiquiti, Cambium, Mimosa, and Microtik, to name a few. Before we begin, just have a little bit of housekeeping to get through. As always, this webinar will be recorded and uploaded to our social media outlets shortly thereafter. So feel free to take a look at our YouTube channel, our LinkedIn account, or even our Facebook account to find it there. If, as the presentation moves along, if you have any questions or comments, please feel free to drop them in the chat window down below as we move along. We will be taking the time to address all questions at the end of the webinar, but if by chance we do run out of time, rest assured that we will personally reach out to everybody that has any open questions. If by chance the chat window doesn't automatically open and there's a bit of a technical glitch, never hesitate to email us, and we'll certainly get back to you quickly. We'd ask, as part of that Q&A session, to pay attention as the webinar goes through, as we will have a skill testing question at the end. And the first person to correctly answer that question will win a $100 Amazon gift card. To be eligible for this, you do need to be a resident of Canada. Here at MBSI WAV, we are extremely excited to see RF Elements continue to innovate at the core of how service providers are building their networks today and for tomorrow. They address and solve some of the major issues facing the industry today as it relates to interference mitigation, throughput bottlenecks, and of course, the overall scalability of access networks. Keep in mind, MBSI WAV and our team can help with planning, network design, pre and post sales support on every piece of a wireless network, including with RF Elements. I don't want to steal anyone's thunder, so I will turn the floor over to Tazos Alexiou, who is a product evangelist at RF Elements, and he will be running the show today. So Tazos, over to you.
Great. Can you hear me okay?
Absolutely.
Excellent. Well, thank you everybody for joining. Today we will be doing our product overview. So if we look at our kind of product map as it is right now, for our horn antenna or antenna line, we break this product line up into three major segments. We have the first are all of our antennas that have a symmetrical beam shape. Then we have antennas that have an asymmetrical beam shape. And then we have our twist port adapters. We're part of our twist port ecosystem for all of the most of the popular radio platforms that are out there on the market today. So what's a twist port? The twist port is simply a waveguide interface. The twist port is what allows us to connect connectorized radios to our waveguide fed antenna system. So it's just a connection interface. It is a proprietary waveguide connector specifically made by RF Elements. This waveguide interface kind of brings in our zero loss concept that we kind of brought to market again over 5 years ago in an effort to say that in order for these kind of higher end radios that we're seeing today, high modulation rate radios that we have on the market, we kind of need to eliminate the external pigtail connectors and kind of go waveguide because it's a more efficient way of transmitting power from the radio into the antenna system. And therefore, it brings a lot of other benefits compared to the old standard of coaxial external connectors. And our twist port adapter is simply that. It's just an adapter, right? The adapter adapts connectorized radios and converts them into a waveguide-based feed. If you look inside our waveguide adapters, you'll see that there's still pigtails inside, but the pigtails are extremely short, extremely low loss, and fixed, where you cannot manipulate them. So that therefore, you know that you're getting near zero loss when you use our adapters with the popular connectorized radios that are on the market today. So we offer different types of twist port adapters for different types of connectorized radios. So most popular radios have 2 SMA connectors on top, and we have the sort of slip in and lock type adapter like this PAF adapter that we saw. We also make adapters for waveguide fed radios like Mimosa's C5X that we see here, and other waveguide fed radios on the market from Ubiquiti. They have the ISO station and the Prism station, and even the new Force 420 series or 425 series from Cambium. And third, we have our kind of enclosure twist port adapters that are usually popular for things like Microtech that allow you to put a router board inside and then connect them to our waveguide interface. So these are like the 3 different types of twist port adapters that we have. And all of the twist port adapters that we make are unique or semi-unique to very specific radios themselves. So it doesn't matter which twist port adapter you are using, all twist port adapters are 100% compatible with all of our twist port enabled antennas. So whether you're using a symmetrical horn and you want to switch to an asymmetrical horn, the twist port adapter that you have for your radio will work with any of those. Even if you switch to one of our parabolic dish, ultra dish antennas, or even our ultra horn, the twist port adapter connects to any of our twist port enabled antennas. So as I mentioned earlier, we make twist port adapters for many of the major radio manufacturers that are out there, like Ubiquiti Networks, Cambium Networks, Mimosa Networks, also Microtech, and even all other 5 gigahertz connectorized radios that are on the market. So as you can see, all of these adapters have some slightly different form factors, and those form factors are only to interface with the radio that you use, but you can see the waveguide interface, the twist port interface is the same, and therefore, again, it makes all of our twist port adapters 100% compatible with all of our twist port enabled radios. So for Cambium Networks specifically, we have one adapter, it's called the twist port adapter Epmp. And this works specifically with the Epmp line. It's compatible with the 3000s, the 3000L, the 3000 or the 300 CSM, the older Epmp 1000 radios, and so on. We have a second adapter now. It's the Epmp Adapter E2k. It was originally created for the Epmp 2000 radio from Cambium, but it's also now compatible also with the Force 400C series the new 802.11ax radio from Cambium Networks as well. For Ubiquiti networks, we make, again, a wide range of adapters. We have the twist-port adapter PAF, which stands for Prism Air Fiber. This one adapter works for all of the Rocket 5 AC Prism, the Gen 2 Prism, the Air Fiber 5X, the 5X HD, and even the newer LTU Rocket. We have some legacy adapters still available for the old Rocket M5 and also the old Rocket 5 AC Lite for people who are still using those. And then we have the twist port adapter IS for the ISO Station and Prism Station series of radios from Ubiquiti Networks. For Mimosa Networks, we have an adapter for the C5C radio, the C5X radio, and we also have a new adapter for the new A5X, which should be coming soon into the market. And then finally, for Microtech, we offer two different twist port adapters. We have the RBC, which is the router board cast aluminum. It's an all aluminum enclosure for harsher environments. And then we also have the RBP, which is plastic. Again, both of these are compatible with kind of the same form factor, 911, even the older 711 and the new M series boards from Microtech. And as I mentioned earlier on, any of our twist port adapters are 100% compatible with any of our twist port enabled radios, antennas. The only thing you need to know is you have to have the right adapter for the radio that you use, and it will work with all of our antennas. And then finally, we have a connectorized twist port adapter. It's a TPA SMA. And this adapter is basically for all other 5 gigahertz radios that are on the market today that we do not have a twist port adapter for, where the radios kind of slip and lock into place. So if you're running, let's say, Cambium PMP 450i series, if you're running the Mimosa Networks A5C radio, maybe you're doing a backhaul with a B5C from Mimosa, or even a 550, PTP 550 from Cambium. Again, you name it. If it's a 5 gigahertz radio and we don't have a customized adapter for it, the TPA SMA is the adapter that you would use. You use basically LMR jumpers to connect to that unsupported 5 gigahertz radio. Now, we have a ton of adapters and a ton of different twist port enabled antennas in our portfolio. So we have this little cheat sheet that you can find on our website, rfelements.com, just in case you want to reference back and you're unsure of which adapter to use for the radio that you have. You can simply use this cheat sheet that we've made on our website. So now we'll go into our horn antenna technology, and we'll talk a little bit about what makes horn antennas very unique, very efficient, and highly clusterable, right, in order to create very dense networks at your tower site. So the first thing, which most of you may have heard or might know already, is that all of our horn antennas have absolutely 0 side lobes. So if we look here, we're looking at an antenna simulation. This is a simulation file that simulates the RF that comes out of an antenna and basically the design software when you create antennas. And on the left, you're looking at one of our 90-degree symmetrical horns. You can see the RF comes out. It's very uniform. It's very controlled, and it's very forward-facing with 0 side lobes. If you compare this to kind of your traditional 90-degree patch array sector antenna on the right, you can see how it's not, very directional. There's huge side lobes on the sides, a lot of leakage out the back, and you can clearly see the difference between an antenna that has side lobes versus one that doesn't. And this is how we achieve a lot of the noise isolation, because you know that you're only sending signal to and hearing signals from the direction that you intend to when you use our antennas. Another great benefit is the beam efficiency of our antennas. So beam efficiency is basically a measure of side lobes. It tells you the percentage of energy that comes out of your antenna and how much of it is in the main lobe where it matters compared to the total output, right? So you can easily do a calculation and see how efficient basically a radio is and how little side lobes it has by measuring its beam efficiency. So, beam efficiency really makes comparing, two antennas in terms of side lobe performance really easy, right? The higher number wins. So in this example, we can see the symmetrical horn has a beam efficiency of roughly 94% compared to your traditional patch array sector, which has a beam efficiency on average of about 69%. So what this means is that 94% of the energy in a horn goes into the main lobe, and only 6% is in the side lobe. In your traditional antenna, you're wasting over 31% of the output power in a side lobe, and it's not in the main lobe. So clearly, a 94% beam efficiency antenna is a lot better in terms of noise than an antenna with a 69 or less percent beam efficiency. So if we look at all of our horn antennas, when we design them to be at a minimum of 90% beam efficiency or more. And here you can see in our symmetrical horn series line, they range between 90 to 94%. In our asymmetrical horn series of antennas, you see that they range between 90 and 95%. And then ultimately in our ultra horn, which is our highest gain horn antenna, you can see we have a beam efficiency of 99%. So that means practically all of the output power from your radio is going in the main beam. None of it is being wasted in some other direction other than where it's focused, which also means it's only going to hear signal from that direction that it's focused. So beam efficiency is a really important parameter and something that is really, really unique to our antennas as far as having a very high beam efficiency. So really all these things, lack of side lobes, high beam efficiency, this really, creates a kind of co-location miracle, right? Because you have no self-interference between antennas. You have the ability to really co-locate lots of antennas together on the same tower and really create some high density deployments and extremely high aggregate throughput availability on your towers, where you can see with, the competitors or competing kind of sector antennas out there, you can see how all the side lobes, receive noise, create noise for the adjacent sectors, and therefore really reduce the overall network throughput of not just that particular tower overall, but every individual access point on that tower. So now, really this kind of co-location, we talk about it a lot. You can see it in our spec sheets and our polar plots. But we know that, the market is used to seeing a lot of marketing fluff that's out there, right? They're used to having manufacturers tell them how great their stuff is. It's perfect on paper. But when you put it out in the field, it really kind of falls apart, right? And it doesn't really perform. These pictures right here are actual installations out in the field. So it's not just us saying that you can densely co-locate these antennas together. You can actually see in the real world, it's actually happening and it's really functioning that way. So it's quite amazing if you haven't used it, and you kind of have to use it to see it for yourself. Some of the other benefits that our horn antennas bring is that they are very stable across a very wide range of frequencies. And this is really important because when you're deploying a network, your coverage area is dependent on how your antenna preserves or keeps the spec pattern that you see on the spec sheet. And you can see with our horn antennas, as you sweep from the lower 5 and up even past the 6 gigahertz spectrum, you can see that the main beam doesn't really change shape much. If you look on the right, you can kind of see the two-dimensional coverage pattern basically on a map, and you can see it fluctuates very little. So your coverage area doesn't change. If you compare this to the instability of a patch array sector, you can see how the actual coverage pattern changes dramatically with frequency. So what really is one of the driving points here is, and I'm sure as a WISP, you've seen it before, where you at some point you run into noise and you're forced to change your channel. And you do your spectrum analysis and you say, okay, I see channel whatever, 5250 or something like this, has no noise. So I'm going to jump to that frequency, and you jump to that frequency and you change it. And all of a sudden you have customers that had good signal that now have a marginal signal, right? You have people who weren't in the coverage area who now are, or vice versa. People like to attribute that to noise on the new channel. But we know that's not the case because you did your spectrum analysis and you saw that there wasn't. What's really happening is the gain performance and the instability of the pattern at that new frequency has changed that coverage area. And that's why signals drop. Sometimes they improve, but overall, the people that you had covered from that sector now have some adverse effects. And that's because of the instability of the pattern at different frequencies. We can see this in the gain stability of traditional sectors compared to horn antennas. So not only does the frequency or the shape of the beam change with frequency, but also the gain changes. A lot of people like to buy antennas based on that kind of max gain that they see on the spec sheet. But what you don't often know is at what particular frequency, and sometimes at what particular polarization that frequency, that gain is spec'd at. So if we look at the red curve here, you can see on mainstream patch array sectors, you can see that gain can drop off really fast as you cross over a particular frequency, and you can see it peak and then drop. So there's kind of a sweet spot for performance on a patch array sector. If we look at the green line, it's a horn antenna or our horn sectors. You can see that no matter where you are in your operating frequency, that the gain is pretty much flat and stable across the entire spectrum. So when you change a channel to maybe avoid noise at some point, your coverage area isn't changing, and that the gain that you're delivering is also not changing. So it's a very reliable antenna to use. Our, horn antennas, have many different, we offer horns in many different beam widths and also gain. So this is kind of a chart of our symmetrical and asymmetrical horns. And you can see everything from 30 to 90 degrees wide in our symmetrical horns, from 30, 40, 50, 60, 70, 80, 90. And then you could also see our asymmetrical line. We have a 30, a 60, and a 90 degree asymmetrical horn, and you could see its gain. And then obviously the ultra horn at the end, which is the most narrow beam antenna that we have, and its delivered gain. So really, as I mentioned earlier, all these antenna options are there for a reason. They're not just to make simply another SKU to sell to you, but it's there so that way you can actually build your coverage where your customers are and not send signal where your customers are not. It's also helpful to use sometimes lower gain antennas when you have tower sites that are facing each other, right? So you could use less gain in order to not interfere as much with an adjacent tower. You could use wider antennas where you have lower density customers. You could use more narrow antennas where you have higher density in order to go ahead and, again, kind of build this coverage out and appropriately allocate the types of density that you need at your tower sites. So here's just a representation of the different beam shapes of our horn antennas, again, in reference to patch array sector. So if we look on the left, this is the rough shape of a patch array sector, and you can see all the side lobes on the top and the bottom, and they're usually extremely, extremely wide. You can see in the center is our symmetrical horn antennas. This is what their beam shapes look like. And as the name says, it's very symmetrical. So it's just as tall in the elevation cut as it is wide in the azimuth cut. And then finally on the right, we're looking at our asymmetrical horn series. So you can see it's more of a sector feel where it's much wider in the azimuth and not as tall in the elevation cut. But these are the different shapes to try and give you a visualization of how the RF projects out into the field from our antennas and the orientation of those antennas. If we look at the coverage pattern, we can see that a patch array sector usually has a very narrow elevation beam, where symmetrical horns usually have a much taller elevation cut, and our asymmetrical horns have a more narrow, but somewhere between our symmetrical and asymmetrical pattern. So again, these different types of beams are useful for different types of deployments in hilly areas, in valleys and stuff where, you're actually with our larger elevation cut, you can cover close-in customers to the tower and further out customers from the tower without having to manipulate down tilt too often, where with a patch array sector, sometimes you have to deploy more than one with a lot of down tilt for close in and one with less down tilt for further out. But our unique coverage patterns on our horn antennas allow you to kind of meet it in the middle and manage it a little better. So let's look at what horn antennas look like with down tilt versus patch array antennas. So here we're looking at, again, another simulation. As we start down tilting a standard patch array antenna, this is what a symmetrical horn antenna looks like. So you can see that you can actually adjust quite a bit of down tilt and still preserve the coverage area, where with a traditional sector, if you go sometimes more than like 5 degrees of down tilt, you really start to lose the coverage area 100%, right? So we'll go back here and you can see, if you look at the down tilt here, we're at 2, 3, 4, and at 5 degrees of down tilt, your coverage area almost disappears, right? So a horn antenna gives you a much more stable coverage with down tilt with much better resolution. So you can actually adjust the down tilt to again, cover the distance that you want and not, adversely affect what your coverage area is like. Our antennas are also very compact, right? So our symmetrical horn antennas are roughly about the quarter of a size of a traditional sector antenna. And our newer asymmetrical horns are roughly about 40% the size of a traditional sector. So what we're saying here is you can put anywhere from 2 to potentially 3 or 4 of our antennas in the same vertical space as one traditional sector. So you can see they're very efficient when it comes to mounting as well, and the ability to co-locate many of them in the same space as a traditional sector. Our 30-degree asymmetrical horn also has a unique feature we call beam switch. So by default, the antenna is 30 degrees wide and 20 degrees tall, but we have the ability to just rotate that antenna 90 degrees within the mount itself. And now you can repurpose that same antenna as a more narrow 20-degree wide horn antenna if you want, and that will give you a 30-degree elevation cut. This is really important because we see customers every day building out 12 horn towers, right, with 30-degree horns, giving them 360 degrees of coverage. But we have customers that are going beyond 12 horns. And if you need more density, you need a more narrow beam. And with our asymmetrical 30-degree horn, you can use the beam switch feature and deploy it as a 20-degree wide antenna, and therefore get up to 18 antennas for 360 degrees and therefore extremely high density. All of our antennas have a very innovative mount, right? So I know most of the WISPs out there are used to installing parabolic dish antennas and sector antennas from other manufacturers, and you usually have multiple long lag bolts and washers and lock washers and nuts and all the other things. So our innovative mount is really only a 2-screw mount. It also allows you to flip the bracket in order to accommodate larger or smaller diameter pipes. So this is something very unique in the market that we kind of brought. So here, again, it becomes very simple with just a matter of 2 bolts, and it makes it simple for, you know, a single installer to go ahead and install these antennas in the field, sometimes with only one hand. You mount the mount to the pole, and then you slide the antenna in, you adjust your azimuth and you adjust your elevation, and you're pretty much good to go at that point once you lock it all in. So this, again, very unique to RF Elements, and much different than what you've been seeing over the past 10 years in the industry as far as mounts go. All of our antennas are very durable in their build. We use all high quality, non-corrosive materials like extruded aluminum, zinc alloys, stainless steel, UV resistance, HDPE plastics, and even some high quality zinc coating on some items. So our antennas are built to last in, you know, very rough environments, and no steel to rust or corrode on you. Again, here are just some more deployments that you can see in the field of our products, again, kind of showing off the clustering capabilities of our antennas. And again, it's to just really show you that it's not just in the spec sheet, it's in practice. It's definitely something that's possible, and we see every day out in the field. So we're going to quickly go over some of our radio connectivity options. So again, we have our twist port horn antenna series of antennas, right? So we have the symmetrical horns, which are, again, from 30 to 90 degrees wide in 10-degree steps. Then we have our asymmetrical twist port antennas. We have the 90, the 60, and the beam switch feature in the 30 that allows it to run in 30-degree or 20-degree wide, as well as our ultra horn for, again, the horn antennas that are compatible with our twist port ecosystem. Again, any of our twist port adapters are 100% compatible with any of these twist port enabled antennas. We also offer carrier class horns. The carrier class horns are exactly like our twist port horns as far as performance. They're available in 30 to 90 degrees and 10-degree steps. In our symmetrical series line, we have the 60 and 90-degree asymmetrical, and then we have a 30 or a 20-degree version in carrier class, as well as our ultra horn. So again, the RF performance, the beam width specs and gain are the same. The only difference is that these are not twist port enabled, and they have built-in end connectors. So the reason for this antenna line is for a customer, let's say, that is using only a non-supported twist port radio, like maybe you're PMP 450i customer, you know you're never going to use anything other than the 450i on your APs. So it doesn't make sense to buy a twist port antenna with the SMA adapter we showed earlier. You know, you might as well get the antenna with the end connectors built into it. Also, for people who prefer an end connector on their cable versus an SMA, like in our SMA twist port adapter, the carrier class horn line is probably best suited for you. We have some new accessories that are coming out soon. Some of you may have seen us advertise our twin horn bracket, which is pretty close to shipping. It should be available in May of this year. And the twin horn bracket is made to integrate basically with the Epmp 3000, which is the Muy Maimo 4x4 radio from Cambium, and even the A5C from Mimosa. So if you're using one of these radio platforms, you are welcome, or you can use this, and it has built mounts specifically to mount those radios right to the adapter. It gives you a single mounting point to the actual pole. And you could also use these with our twist port antennas if you want, with maybe prisms or some other radios. Some useful ideas that people have is using these as a hot backup as well. So let's say you run a rocket prism, you can have two horns with two rockets on it. You keep one active offline and you utilize the other one. So for maybe a extremely, high capability or high utilization radio, something for customers that need, a very high SLA, something like that. You can basically have a hot standby radio waiting in the second position that you can switch on and off if you happen to lose one of those radios. So there's a lot of different options on why you would use this bracket, but these are just some of those options. And then we have our parabolic dish antenna, or our ultra dish series of antennas. So we offer two different varieties here. We have the ultra dish 550, which is a 550 millimeter dish with a gain of 27.5 dBi. And then we have our ultra dish 400, which is a 24.5 dBi parabolic dish antenna. These dish antennas, again, are twist port enabled. So if you're already using a radio with a twist port adapter on a different antenna, you can simply take that twist port adapter and radio and plug it into our ultra dish series of parabolic dishes and use them for point-to-point or CPEs or however you want to use it. Some of the unique features, or the important features to note on our ultra dish series, is that we've done a lot to suppress the side lobes. So I know we spent a lot of time talking about RF Elements horn antennas and zero side lobes and high beam efficiency and lack of side lobes. I always take a moment to make sure that people understand that our parabolic dish antennas still have side lobes. All dish antennas have side lobes. Side lobes are inherent to that particular antenna type, just like all patch array sectors have side lobes. All parabolic dish antennas have them, but we've done a lot to uniquely shape our dish and our feed to try and suppress them as much as possible. So we have a pretty decent beam efficiency on this antenna. And again, it's unique with its twist port capabilities. Another thing that we focused on when creating the antenna was not only suppressing the side lobes, but to try and give you as much stable gain across the entire spectrum as possible. And not only flat gain, but also the same gain in both polarities, which is, again, very important, right? So both our horizontal and vertical polarization have the same gain, so we can chart it with a single line. And you can see from 5.1 to about 6 gigahertz, there's only about 1 or 2 dBi of difference in gain across the entire spectrum for our 400 and the 550 series. These antennas are really great for high-end CPEs and high noise environments. A lot of people like to deploy patch panel antennas, and they have lots of side lobes. So in like these mimosa urban settings where you have lots of access points, those side lobes can hear the noise from other access points in that coverage area. The suppressed side lobes of our ultra dish really make it a great antenna for CPE in these high density areas, because they, again, have less side lobes and better beam efficiency than a lot of the directional patch array antennas that people currently use. And again, we're talking about those kind of square flat panels that a lot of people like to use. They're horrible when it comes to side lobes, and our ultra dish is a much better choice in these types of situations. Again, you could see some of the deployments out there. We see them again with air fibers. We see them with Prism, Mimosa, all the radio manufacturers. Again, the twist port interface on our ultra dish is compatible with all of our twist port adapters from all the radio manufacturers. And then finally, we have a new patch array sector antenna. So we had a carrier class sector line over 7 years ago. We've kind of redesigned that antenna and brought it back to market. It's the array sector 520. It's a 5 gigahertz, 20 dBi sector. And you can see here, it's measured at roughly, 80 degrees wide at the -3 and 100 degrees wide at the -6. People typically utilize this as a 90-degree sector. Something that's very unique to our antenna is that we have a built-in back shield surface. So this back shield is integrated into the antenna, so you don't need to use and really ruin the performance of your antenna with some third-party shield kit. The back shield is a specifically designed frequency selective surface, and it's created in order to attenuate a lot of the parasitic RF that comes from the traces in the actual patch array, and it helps us form and balance the beams. If you look at traditional sectors that are out there in the market, like you see here on the right, the mainstream sector, typically you'll have one polarity is much wider or more narrow than the other polarity. And typically what happens is a manufacturer will have the vertical polarization, let's say, is 100 degrees wide, and the horizontal is, let's say, 80 degrees wide, and they'll average that and sell it to you as a 90-degree sector. This creates lots of problems, as you can see, with these mismatches in beam pattern. You can have customers that will receive one polarity at a higher magnitude than another, which would give you these huge chain mismatch errors that you've seen that make your radio modulation rates jump around. On the left, you can see the simulation of ours, and we spent a lot of time trying to ensure that both the horizontal and vertical beams are as matched and balanced as possible, not only in gain, but also in their width. Again, here you can kind of see the spec gain, stability, and VSWR for our antenna. So it's quite impressive to be, basically like at 1.5 or below in VSWR across the entire user spectrum. The kind of industry standard is to be less than 2 for VSWR. We're at 1.5 or less. And you can see our gain from 5.1 to 5.9 is pretty much 20 dBi. So all the problems we talked about earlier for beam stability and the gain changing in sectors, we've gone through and kind of revamped sector antenna technology and brought a lot of the stability that we have in horns to sector antennas. But again, our array sectors have side lobes that can't go away, basically. As far as radio connectivity, the back of the array sector has that kind of slip and drop and lock into place that you've seen on antennas in the past. And again, it's compatible with a lot of different manufacturers, Ubiquiti, Mimosa, even TP-Link and Cambium, right? So all these different radios are able to slide and lock in place. And it's got built-in, again, high quality, semi-rigid pigtail connectors in there to help ensure that you have a watertight connection, a low loss connection, and a highly reliable connection interface with all of these different radio platforms. So, at RF Elements, we really are setting new industry standards. I mean, we kind of brought it, to bear over 5 years ago now, I believe, with the introduction of noise rejection. We kind of took this new approach to say, why are we trying to fight noise with more power and higher gain? It seems like an endless battle that all the manufacturers are doing out there. And we decided to kind of revamp everything and find an antenna type that was more suitable, and then redesign it in a very unique way in order to reject noise and really give you a lot of capabilities. The same thing with the zero loss system that we, again, kind of revitalized and brought to market over 5 years ago, that you're starting to see now from manufacturers. A lot of manufacturers in the 5 gig spectrum are starting to make radios with waveguide interfaces because they're more efficient. So again, these are the kind of standards we've brought to market, and we've kind of innovated from the beginning. And really, when you combine this kind of low loss, high efficient radio method, right, with noise rejecting, well-balanced antennas, you get this massive scalability that we really need as a network operator. We know that the need for internet has grown almost exponentially over the past few years, extremely fast over the last year for the number of internet connections that you need to deliver with everybody working from home. But not only did you have to deliver more internet connections, you also needed to deliver faster internet connections. And so you need a technology partner that will allow you to scale on a massive level to supply all those connections at those higher throughputs in order to really keep things going. So that's kind of our antenna thing. We'll close it off here with some other products we have. We have some integration platform products. We have the Station Box Alu Mini, which is a compact enclosure for kind of builders and DIY guys that are doing maybe some IoT applications for wireless platforms and stuff like that. It's a die-cast enclosure that allows you to put your own boards on the inside, and we have 3D data available for board customization and even 3D printing of the mounting plates inside. So this is a product that we offer. It's pretty cool the way it mounts to either a pole or the wall, and the radio or the enclosure itself just kind of slips and locks into place. So that's kind of cool. If you're going to mount it to a wall as well, it comes with screws. And then we have our Station Box Alu. Again, this thing has been around for a while. It has 6 end connectors and 1 Ethernet pass-through. It's a very large enclosure that has a lot of room inside, again, for some kind of custom third-party boards, or maybe you have some special project that you're building on. Something new that we've brought out recently and started to roll out is our new surface coated hardware. So for customers that have used our products and you've seen it before, you're used to our stainless steel hardware and having to use anti-seize. You should start seeing these new surface coated black kind of coating on our stainless hardware that now you no longer need to use anti-seize. So this polymer that we have created to put on our bolts allow you to really insert these screws and no longer have galding issues that you may have had in the past. So it's being resolved, or it's been resolved. We do a lot, as much as we can, at least, for using ecological packing and reducing styrofoam and reducing the impact to the environment with cardboard, and most importantly, recycled cardboard for all of our enclosures. For people who are interested in where you can buy our products, we have a stock locator on our website, which is integrated into most of our distributors' stock levels. So you can simply click on the drop-down menu, pick the particular antenna or adapter that you're looking for, and it'll show you globally where it's available and where it's in stock. So that's something cool that you can find at rfelements.com. For those of you who have the question, how far can your antennas go? We've really spent a lot of time building our new link calculator into our website. It's very unique. It uses MCS tiles to kind of show you not just what the signal will be at a certain distance, but at what MCS level you should receive in those coverage areas. Again, it's something unique that RF Elements brought to market. Again, a new way of visualizing your coverage area based on estimated MCS rates in those coverage areas. And then you also have the ability, because we've updated it and added manufacturer radios to the drop-down list. So if you're using Cambium, you can pick out of the list the 1000, the 3000L, the 450, the 325 CPE, and we've built into those calculations the receive sensitivities and MCS requirements for all those particular radios. So that way you don't have to guess when you're populating the application. The same goes for Mimosa. And then we also have some generic 802.11n and AC specs as well. So if you're not familiar with the radio that you're using, you can kind of go off of the AC standards. So it's highly reliable, really cool tool that we have on our website. We ask everybody to join our community, right? So we have an active forum at rfelab.com. and our Facebook groups, RF Elements English, and you'll find us at RF Elements as well. We even have RF Elements Espanol for Spanish-speaking customers. So we're very engaged on social media and on Facebook. So join our community. Also, our educational video series. So we have a lot of information on our YouTube channel, from customer testimonials to interviews to how-to videos and stuff. But our newest endeavor, and again, kind of first to markets, is our Inside Wireless video series, right? So RF Elements, decided that, it's really important to educate customers on how RF works, because it's a very misunderstood and misused technology, right? So what we did is we decided to empower the user base by understanding how things work, and therefore you'll know how to use your equipment better. More importantly, you'll know when a manufacturer is using fluff or trying to blow smoke. So check out our Inside Wireless series and learn about, things like what's QAM modulation, what's the noise floor, what's the difference between antenna polarization and beam width. So a lot of really good generic-based RF information in this Inside Wireless series. And then our trademark disclosure here. So we use third-party trademarks, in this webinar and on our website. We use them solely to state compatibility with our products. All rights of these trademark owners are reserved. And for more details, you can check out our full product disclaimer on our website. So with that, we'll go to our Q&A.
Awesome. Thank you for that, Tassos. That was a great overview of your product line. It's clear, right? In the history of RF Elements, you guys have certainly demonstrated some pretty keen product development, right, on compatibility with some of the top manufacturers. And from the innovation standpoint, when you get down to noise reduction, beam efficiency, co-location solutions, all of that, top notch. I give you guys credit. So yeah, as you were speaking, we did have some questions come in, and give everyone an opportunity. If you have anything else on your mind, throw it in the chat box. What we'll probably do first is I will throw out our question for the $100 Amazon gift card. And if you were paying attention, which I hope you were, Tasso's actually covered this a few times in the presentation, but I'll throw the question out there, and you can take the time to respond. First one in, who's a resident of Canada, will win. And then we'll get to the Q&A. So the skill testing question is, there was several examples of the twist port adapters working with different manufacturers. One in particular was the TPA-PAF, used particularly for Ubiquiti products. The question is which twist port antennas does the TPA-PAF adapter work with? Which twist port antennas will work with that adapter? So we'll let that sink in. Let it be a bit of a race to see who can get their answer in first. But from a Q&A standpoint, Tassos, we got a couple product questions, and then we got an interference question right now. So from a product standpoint, are there any plans to manufacture slant 45 technologies into your products?
So sort of. We do a lot, again, to kind of educate the industry on different types of things. At RF Elements, we are not a firm supporter of slant 45, right? Slant, we know that some radio manufacturers make their CPEs in slant, so there's a reason why you might want that, and we'll go a little bit deeper. But really, slant in most cases is kind of a waste as far as noise mitigation goes, because the short answer is, if you keep deploying slant, you're building up the noise in slant, and therefore you lose that noise immunity that you think you get of 3 dB with slant, right? So we say, have an antenna that has no side lobes, and you reduce the amount of noise you hear greater than the loss of being slant versus HV. So the antennas themselves are non-polarized. They're just waveguides, they're holes. So really, where slant is generated in our ecosystem is actually in the twist port adapter itself, right? So all of our adapters are orientated in H and V. However, there's actually been an Easter egg in our newest adapters for quite some time now. If you pull the adapter apart, you are able to rotate that waveguide inside to make it slant. So the answer is kind of yes. We don't really talk about it much because we really think it's a waste, but for customers that absolutely have to have it, because maybe all of your APs are slant and slant, and you want to use our Ultra Dish, let's say, as a CPE, and you want that radio to be slant, you can twist the waveguide and make it slant. There aren't really many slant radios and manufacturers out there. We know Mimosa is one of the most popular. Yeah, you probably won't see slant. However, again, we give you that ability. If you look at our twist port adapter for the C5X radio specifically, it's part of the setup in there that depending on how you put that adapter, that waveguide adapter on the C5X, it allows you to convert that slant radio to HV if you wanted. So some adapters kind of have it. Some of them are you're able to adjust if you wish by just opening up the adapter and rotating the waveguide. You'll see inside there's a little mark that says slant and a little one that says HV. So you put the arrow pointing in the direction you want, and you can kind of make it happen. Last thing I'll say about this is this slant and HV for the twist port adapters only work with our symmetrical beam pattern antennas. So our new asymmetrical antennas, you cannot do slant on them even if you wanted to, right? So it only works with our symmetrical horns, our Ultra Dish, and our Ultra horns. So
got it. Great. Second product question is, are there plans to create an adapter for the Ubiquiti mesh AP?
You know, I've heard it a few times. People have asked. Probably not. I mean, it's really a something that's based on the demand that's out there, right? Currently, if you really want to use our horn antennas to benefit your radio from Ubiquiti, you could use our carrier class horn, which has connectors on it, and then use LMR. Or if you have our twist port antenna already, you can get the twist port SMA and connect, again, some LMR from it to that. The chances of making an adapter, it's not on the roadmap right now. We've heard the request a few times, but maybe not enough to make it happen right away. So
awesome. We've actually had a handful of more questions pop up here, so that's great.
Great, yeah, keep them coming.
People are engaged. People are engaged. I love it.
I have plenty.
Right. So we have a question about the 2.4 gig Ubiquiti. Since Ubiquiti discontinued their titanium sectors, there's been a hole in smaller sectors. I see RF Elements had one at a time. Is there any plans to bring back the 2-14 carrier class antenna?
Absolutely, and it's coming back even better than before. If you've used it before and you liked it, you're going to really love it. So in the presentation, you saw the asymmetrical or the array sector 520 for 5 gigahertz. We have that same sector being redesigned for 2.4. So yes, it's coming out. Hopefully it's only a few months away. I know a lot of people have been asking for it. We had to get the 5 gig done first. 2.4 is coming. I don't have a strict ETA certainly happening this year. I hope it's happening, you know, by next quarter. So it's been approved. We got to get it through manufacturing and shipping. So I don't want to say soon, but you know, soon.
Will there be 2.4 gig horns coming out as well?
Not anytime soon. Again, you know, horns are unique in what they do and how they work. And there's also some unique challenges to horns, and that's basically their size, right? So, you know, basically if you cut the frequency in half, you're more than doubling the size of the antenna. So it's not that we can't make a 2.4 gigahertz horn. We figure that if we make one, the gain might be too low and the size might be too high, as well as the price for what the market might be willing to pay, right? So we are We are looking at lower frequencies, specifically CBRS. That's basically 3.5 gigahertz range. Below 3 gigahertz, it gets really shady for making a horn again that's cost effective, small enough, and delivers enough gain. So it's not that we don't want to, we just don't think that it'd be attractive. But we're always looking at innovating things, right? So we are working on stuff all the time at different frequencies.
Got it. Where do you guys manufacture your horn antennas?
So manufacturing is done in China and also in Slovakia, where we're based out of. So a lot of the raw components come from China, and a lot of the assembly, testing, and stuff is done in Slovakia.
Got it. Okay, going through the list here. How do horn antennas compare with parabolic antennas in terms of radiated energy efficiency?
Yeah, so I mean, there's really nothing better than a horn antenna. So when it comes to a parabolic dish antenna, efficiency of that antenna, or beam efficiency, as we talked about earlier, increases with gain, right? So the higher you go in gain with a parabolic dish antenna, the higher the efficiency goes, but it's never as efficient as horn antennas. If you look again at our ultra horn, it's basically 99% efficient. I think when we looked at the beam efficiency kind of example of the parabolic dish antenna, I think on average you're somewhere around 60 or 70% in the lower gain, right? So when you jump up to something like 29 or 30 dBi in a dish, you might be as high as in the 70s and 80s. We actually have a webinar. Maybe we should schedule that next, specifically on beam efficiency that we can do. But no, our horn antennas are way more efficient because they have 0 side lobes. So
absolutely. Okay, great. And actually, this kind of segues into the next another question is, will there be any larger parabolic dishes released in the 30 to 34 dBi variety?
No, absolutely. So it's already in the pipe and it's coming, right? So we have a 30 dBi version of our ultra dish that's coming. Yes. Will we do 34 or something, to that effect in the future after that? Probably, but 30 you'll see soon. Definitely this year, hopefully in the next quarter.
Got it. What would you say is the advantage of using RF elements antennas with the C5X over the Mimosa designed horn antenna?
I mean, really don't know. I mean, the one thing I can tell you is we know what our antennas can do, right? So we're not so sure about how the other manufacturers' antennas operate. What I will tell you also is that if you look at the ecosystem that we have, we offer way more horn antennas than any other manufacturer out there, right? So we're the only ones that have a usable asymmetrical series of horn antennas that you don't see out there. We're the only one that has 7 different sizes and shapes in the symmetrical series from 30 to 90 degrees. We're the only one that has an extremely high gain 24 dBi ultra horn. And again, we have the twist port ecosystem, and ours has been proven. So again, I think the user will have to see for themselves. And I can only talk about how I know what our antennas bring to market.
Great. Okay, I think we got one more product question and then another set that kind of deal with interference. But in terms of your parabolic antennas, do you have radomes, and are you planning to have them available if you don't?
So yeah, so for the current line, there isn't, as most people know. Our new one, like the 30 dBi that's coming, there will be a radome available. For our 550 millimeter size, there will be a radome available. Again, this year it's coming, hopefully by next quarter. We are looking at making a radome for the smaller 400 size. That might happen, but definitely the 550 and beyond will definitely have radome support. Yes.
Great. No, that's awesome. That's perfect. So one last question, and it was kind of a little series of questions. When you were speaking early on, you had a chart up there with kind of dealing with massive scalability. You were showing like a tower on a map with a 360-degree view.
Mhm.
And sort of the question sort of worded is like, number one, like how do you prevent interference in the represented coverage area? And from a demarcation standpoint between sections, is it clean? So I'm not sure if you can speak to that a little bit.
Yeah, sure. I mean, it's hard to
Yeah.
kind of explain it all, right? So, you know, people, often like to think that, RF or the beam patterns that you see on spec sheets are like lightsabers, right? Like
Yeah.
where the energy just stops. And that's not the case with any antenna, including our horn antenna. So you see very defined shapes in lobes in our representation of coverage patterns and stuff like that. Clearly, yes, RF goes beyond those, right? We have to stick to uh, some gain area, whether it's the 3 dB drop off or the 6 dB drop off, in order to represent the antennas. Otherwise, it would look like this one non-stopping blob. As far as collocation goes, what we do know is that the self-interference that you see between radios are due to the side lobe interactions, typically not the main lobe that's coming out the front. It's the stuff that's coming out the sides and the back is what interferes. So yes, I mean, it's not like if you have horn antenna A, and then horn antenna B, 2 feet away from it or whatever, pointing in a different direction, they're not invisible to each other based on the way we represent it in the pictures. That's just to kind of explain to you kind of where the signal is going, again, at the -3 or -6 drop off, right? Signal continues to go out in 360 degrees at some level. Typically, the levels that go beyond that -3 or -6 that we show drops off so fast in a horn that, yes, it's there and it's measurable, but it's not measurable in the radios that we use today. You have to use highly sensitive measuring tools in order to see that propagation beyond that kind of -6 or so on. So it doesn't just stop like that. You can't kind of control the zones and stuff like that, but it really does work in such a way that the amount of energy that's there for the adjacent antenna when you're on a different frequency is low enough that it doesn't really interact like when you have high magnitude side lobes interacting with each other. So I hope that answers it. It needs to be more visualized and kind of talking about it. But if you could see me, I was animating this with my hands and everything like that.
Or talking with your hands too, right? No, that's great. I think if anyone that posed some questions. If you didn't quite get, what you were looking for, certainly follow up with your MBSI WAV account management team or with Tassos directly. Obviously, we're here to help. So yeah, I'll make a statement here. People were certainly listening to you talking, because the skill testing question that we posed for which twist board antennas work with that particular adapter, a lot of people got it right, and it was the answer: they all work together, they're all fully compatible. And the winner of our skill testing question is Craig Lull. So Craig, we will certainly be in touch after this. We appreciate your quick answer. So if there's nothing else, I will I'll wrap this up. Tassos, thank you again for your great overview and your information today. We thank everybody for attending the webinar. We appreciate your time as always. Like I just mentioned, please get in contact with your account manager at MBSI WAV if you have any additional information. Like I mentioned earlier, we're going to be putting the webinar live on our social media platforms very, very shortly. As part of a follow-up, we're going to send some RF Elements compatibility sheets for all of their product options. And if anyone has any questions, don't hesitate to let us know. We are very familiar with this product line, and we have plenty of inventory available to support your needs. As always, MBSI WAV will be hosting future webinars. We'll be sure to keep everybody posted on the information as it's released. Dates and times are regularly added to our website, and we encourage everyone to sign up for our mailing list if you haven't done so already. So thank you very much, everybody, and have a great day.
Thank you. Bye now.